The next video here, we're going to determine if there is an association between two categorical variables and describe the association if it exists. So again, very important here topic that we're going to get into talking about association is, so association, this is again very important when we're comparing an association between two. It's knowing the value of one variable. Does knowing the value of one variable helps us predict the value of the other? If not, then we say that there is no association. Okay, and we want to make sure we don't confuse this with association with cause and effect. There could be other variables involved, so it does not imply cause and effect. But again, we can sometimes predict things by looking at data. And we're going to get into a couple of examples of that, but there's a very, very, very important thing. Okay, there could be other variables involved, so don't confuse this with cause and effect. So association, which we're going to talk about a lot in this chapter and in this section, does not imply causation. So just because something is associated doesn't mean that the cause and effect is going to take place. Okay, so let's go ahead and take a look at two bar charts here. And again, we had this example before, but if we look at this, if you look at the first graph, the association, okay, there's association because the female and male bars look different. These bars are looking different. Okay, so we can imply that, oh, you know, if you're a female, more than likely that freeze time was the most popular. I'm sorry, if you're a male, more than likely freeze time was the most popular suggestion. And if you're a female, telepathy was. The second graph, there's no association. Again, there's association in the first graph because the bars look different. If they didn't look different, we would say there's no association. If you look at the second graph, there is no association because they look the same. Females and males pretty much picked the same exact superpower. Okay, so gender doesn't matter here, where gender definitely changed in this first graph. Okay, so if the bars look the same, we say there's no association. So this graph would have no association, which implies that gender doesn't matter. Okay, whether you're male or female in this, you know, we have the same that wanted to freeze time, same that wished they could fly. Okay, whereas we can clearly see that there is an association between females and what they choose, an association between males and what they choose. So moving forward here, and again, kind of looking at the example that we did before with the Titanic graph, says use the graph to determine if there is an association between survival status and class of travel for passengers on the Titanic. Explain your reasoning. We already went ahead and did this bar chart here. So now, first of all, are the bars different? Yes, the bars are different. We can clearly see that. Okay, so they are different, which means there is an association. So in explaining this, this is how I kind of want your wording. There is an association between their survival status and class of travel, because the survival percentages are different. For each class of travel. So if there is an association, we've got to be able to determine what is that association. In this case, there's an association between the survival status and class of travel. And that's because the survival percentages are different for each class. If they were all the same, then we would say there's no association. If all of these bars here were exactly identical, then we would say it didn't matter whether you're first class, second class, or third class, you were more likely to survive just as well as you were to die. But here you can clearly see that third class had less survival percentage than first class did. All right, there's going to be a few problems for you to work on in Edulastic.